Paley Pod, the astronomy podcast for people who are overwhelmed by the universe but want to be its friend.
Hell yeah, that's us and me. Hi, I'm Dr. Moiya McTier. I'm an astrophysicist and a folklorist and a friend to the universe. The universe doesn't have any parties coming up, but I know I'll be invited.
You would. I heard that you're on the list. I am Corinne Caputo, a writer and fun person and friend to the universe. Yay. And I am also going to be invited. If I have the energy, I'll go.
And because it's probably going to be pretty far away, we'll carpool.
Oh, that's such a good idea.
I mean, we'll probably have to, rocket pool to the party.
Yeah, I think that's affordable and good.
It's affordable and good. Corinne, where have we rocket pooled to for this episode's recording?
Rocketed to the top of a lighthouse. And today we are overlooking the ocean, and you can hear some of the waves in the distance, and there are some seagulls flying by. I think they want to come in, but hopefully they can't. But I love being this high up. Everyone looks tiny.
Everyone does look tiny. Even the rocks. We passed the rocks to come into the lighthouse, and up here, they look so wee.
Yeah, and the ocean does look less intimidating.
I can see why people work in lighthouses, because I would find it really intimidating. But once you get up here, the view, it's a whole new perspective.
Yeah, it's really nice. It's kind of what I imagine looking at the Earth from the ISS might be.
Yeah, this is a little taste of
but
that.
But on a much smaller scale. Yeah, exactly.
Being on the ISS is like the whole salad, but being at the top of this lighthouse is like the little microgreens.
Yes, exactly. It's the little sprouts that are typically very expensive for a little dollop.
tiny little bit. But apparently they're super nutritious or something.
I know. I can't imagine. I don't understand how vitamins work. I don't know how they fit it all in, but
me neither. I'm not that type of doctor. That's my favorite line to say whenever I don't know anything. I'm not that type of doctor.
I can say that for anything.
You can. Yeah. When it comes to astronomy, if I don't know something, I gotta be like, oh no, I am that type of doctor. And I'm just failing.
No, then you just say,
things.
Oh, I'm always learning. Learning is a lifelong journey.
Oh my God, yes! I love that. I love that. Speaking of learning, today we are going to be learning about another telescope. This is the second installment in our non-contiguous series on different observatories and telescopes. The first one we did, which was the last one we did, was all about the Hubble Space Telescope. But today we're gonna bring it back down to the ground. We're talking about the ground-based telescope of my heart, of my dreams. It is the Robert C. Byrd Green Bank Telescope.
Yeah.
Yay. Corinne, have you heard of this telescope before?
I have not, but I did look up an image of it, and I feel like I've seen a picture of it before, but I just haven't married the name in the photo.
Yes, I think you probably have seen a picture of it before, because it's kind of a famous telescope, as famous as a telescope can be. It does have a really impressive claim to fame, and I'm wondering if you could guess what it is.
Is it the size? Is it how big it is?
It does have to do with the size, yeah. Size matters here today.
Is the diameter the biggest?
Yeah. So the Green Bank Telescope is the world's biggest steerable single-dish telescope. There are bigger telescopes. RIP to Arecibo down in Puerto Rico. It was bigger than the Green Bank Telescope. There's also a telescope called FAST in China. It's the 500-meter aperture systems telescope or whatever. It's FAST. But those telescopes couldn't move. They were big dishes that sat on the ground and stared up at the sky above them. The Green Bank Telescope is fully steerable. So it can pivot from place to place, which is impressive because it's so big. Actually, you know what? In all of these numbers that I looked up, I did not look up the weight of it, but let me do that real fast.
I almost looked up the weight of it. So I knew it was big, but I didn't know it was the biggest of its kind. But I was thinking, we'll play a little game at the end of the episode, and I was wondering if we should also compare weights to other things, but I did not look up how much it weighs.
Oh my God, I did! Corinne, it weighs 17 million pounds!
No.
Yes, it does. Oh my God, that's a big boy.
Can the ground support that? Like, what is the structure?
Well, they have had to raise money in the last decade or so to fix its foundation. So yeah, it's kind of a problem. And we'll get into the history of the telescope later on in the episode. But like, yeah, it's big.
It weighs that much and it can still move is insane to me.
I know, and it's tall. It might be taller than this lighthouse. Actually,
I think it's over 100 meters. Yeah, I think it is. Well, it definitely is.
All right. Well, let's just, while we're like speculating about these numbers, let's go into the notes that I took that have the actual numbers for it. All right. So, like I said before, the Green Bank Telescope is the world's largest steerable single dish telescope. There are bigger telescopes that can't move, and there are bigger arrays of telescopes like ALMA or the VLA, which you may have seen in the movie Contact. Another great movie. The Green Bank Telescope is more than 300 feet across. It's 100 meters in diameter. You could fit multiple American football fields on this telescope.
That is so big. That would make me feel so tiny.
It's so big. I've been there. I have been to this telescope twice, and I'll tell you the stories later in the episode. But yeah, it's big. It just like dominates your field of vision when you're standing next to it.
Wait, where is it? Did you say that already?
Not yet. Not yet. So it's multiple football fields. It has a collecting area of 2.34 acres.
That is big.
Acres. This is a telescope whose size you can measure in acres, which just boggles the mind.
That does sound crazy.
It weighs 17 million pounds, and it stands over 485 feet above ground level. It's almost 500 feet tall.
No, too big.
Too big. It's so big. And here's some information about like its accuracy and what it actually sees. So it observes in a range of wavelengths from 2.6 millimeters all the way up to 3 meters. That's a really big range. It's a huge range of the radio wave region of the electromagnetic spectrum. If you haven't listened to it, go back and listen to our episode on the electromagnetic spectrum so you can learn more about radio waves in general. But that's a big range. In case you are more comfortable thinking in frequency instead of wavelength, frequency tells you like how often do the light waves pass you as an observer, then the frequencies that it observes are 0.1 to 116 gigahertz. A hertz is like 1 time per second, so 116 gigahertz is 116 billion times per second.
Oh my gosh, a lot.
Yeah. And because it is observing in radio wavelengths, it doesn't have to be a smooth mirror finish like an optical telescope does. So you can actually stand on this telescope. It does not look shiny, but the surface of the telescope is perfectly smooth to the noise levels that they care about. Anything below a size of like 5 human hairs is not going to be picked up by this telescope. Like that's the amount of noise that it can see over.
You can walk on it.
You can walk on it. The resolution of this telescope is good enough that you would be able to see a quarter 3 miles away.
Oh my God. That is so good.
I know. These telescopes are amazing.
I can barely like read signs. I'm wearing my glasses today for like the first time, and I'm like, oh, this is like I'm seeing in 4K.
I know. I have to like get my face right up to the computer to see my notes, but this telescope could see a quarter 3 miles away, and I know. It sees about 85% of the sky because it can move around. It sees everything that is above 46 degrees south latitude. So it sees most of the sky. It operates 24 hours a day, 362 days a year. It needs a break. Yeah. It needs its vacation days. It's part of a union.
I was going to say,
not a very
it's
successful
a bad union. Yeah. He could get a little bit more benefits for him.
So that's like its operation, but it is not always doing observations. 24 hours a day, 362. Like, there are other things that they have to do with the telescope, like point it to an object to calibrate itself, or like maintenance on the telescope. When we're just talking about observations, like the scientist has asked the telescope to look at a certain target in the sky, that's more than 6,500 hours every year. For every hour of time that you're allowed to observe on the Green Bank telescope, roughly 4 hours are requested. So they are only able to grant a quarter of the time.
Oh, wow. That still feels like a lot. Like higher than a lot of like acceptance rates at schools.
Kind of. The time allocation committees, the people who decide what observations get time on the telescope, they have a hard job, and I do not envy them that.
I don't want that job at all.
But scientists from around the world can request time on this telescope. Students get time on this telescope. I have a friend who got GBT time as a grad student, and like that's really cool to be able to use this groundbreaking telescope as a grad student.
Yeah, for sure.
Is awesome. On to the money, the money of it. So a lot of the money for the GBT currently comes from different universities and colleges, the National Science Foundation, and the state of West Virginia, which is where the observatory is. Over the last 5 years, all of those different groups have collectively contributed $25 million to the maintenance and upkeep of the Green Bank telescope. The money from the National Science Foundation is about 0.1% of all of the money that the National Science Foundation gives for astronomy research, which is like a very tiny number.
Yeah.
But considering all of the things that NSF funds for astronomy, that's an appreciable fraction. The observatory is bigger than just the Green Bank telescope. It also has a science center, a tourist and visitor center. They have a machine shop where they build a lot of electronic equipment, and it's like a separate electronics laboratory where they're testing different electronic equipment. And they have 7 other telescopes spread throughout the observatory land, which is in Green Bank, West Virginia, on the western side of the National Radio Quiet Zone. Corinne, have you heard of the National Radio Quiet Zone?
No, I haven't.
Oh, that's so exciting. The National Radio Quiet Zone is such, a feat of civilization to me. The fact that we have carved out this space and decided that it is protected from something as like ephemeral and intangible as radio frequencies. So let me just explain what it is. It was established in 1958 by the Federal Communications Commission, so the FCC, and the Interdepartment Radio Advisory Committee. The two groups together in 1958 set aside this big plot of land to minimize possible harmful interference to the National Radio Astronomy Observatory, which was already there, and a radio receiving facility that the Navy uses in Sugar Grove, West Virginia. So there are these two, there's a research facility and a military facility that needed like unfettered access to radio transmissions and radio wavelengths. And so the government came together and decided to make radio emissions kind of illegal in this big zone. The zone itself covers 13,000 square miles straddling West Virginia and Virginia and a tiny fraction of Maryland up in the north. And the zone is divided into roughly concentric regions with varying levels of restriction. So zones 1 through 5. 5 is at the very edge of the radio quiet zone, and the rules there are kind of loose. But as you get closer to the observatory, the rules get a lot more strict. So there are a lot of things you're not allowed to do or use in the center of the quiet zone. So you can't use cell phones.
Okay.
No Wi-Fi. You have to use Ethernet. You can't use a microwave unless it's in a Faraday cage to like block in the radiation. You aren't even allowed to use a gas-powered vehicle because the spark plugs in a gas-powered car, that little ignition, does create radio waves. It creates radio transmission. So you have to use diesel-powered cars to drive around the observatory.
Oh my gosh.
And like there are people who live around the observatory. The people who work at the observatory live around there. The observatory itself does have dorms and a cafeteria. All of the microwaves are in Faraday cages.
Oh my gosh.
But there are other people who live beyond the observatory, and they live their lives according to these rules. The NRAO, the National Radio Astronomy Observatory, doesn't have any sort of enforcement mechanism. Like, there are no radio astronomy police. which is a good thing.
Yeah, probably the best.
Definitely for the best. But they can issue you a fine if they receive any sort of radio interference. They can come to your house and investigate the source of that radio interference. So, like, one day, if you accidentally used your cell phone or something, like, they can come in and be like, "Sir or ma'am, did you use your cell phone on this date?"
Oh, no. Me on TikTok being like, "No, I didn't. It wasn't me."
And then if you say yes, or if like they determine that the interference came from your home, they can issue you a $50 fine.
Okay, that is so much less than I was gonna say. It's like, you know what? A self-care day. I need to scroll. I'll just pay $50.
Just $50. Oh, I love that. You also can't use digital cameras,
okay.
But film is fine. Mm-hmm. Yes, that's the
and you can't like play the radio.
Correct.
Okay.
Correct. Oh, actually, you know what? That does take me to a point that is not in my notes, but it should have been. My favorite poster, Corinne, my favorite poster in existence is the radio frequency allocation chart for the United States. It takes the entire band of radio wave frequencies, and it's color-coded, which is part of why I love it.
Of course.
It shows you all of the ways that those frequencies have been divided up into chunks. So radio astronomy gets a chunk, and like the radio, you know, the thing that plays music in our cars, that gets a chunk. Mm-hmm. Communications for different groups get their own chunk. So like the military has a communications chunk, the like telephones are phone towers, they have their own chunk. And it's really cool to see how these wavelengths are split up among all of these different industries. It's also kind of sad because radio astronomy gets very little.
Aw.
Yeah. And so sometimes I think about how far along we would be in astronomy if we could just use like the whole range of radio wavelengths in our research. But then I remember that there are other radio telescopes elsewhere in the world that have the ability to observe in different wavelengths, so like it's fine.
Yeah.
It is fine. But yeah, that is my favorite chart. And so you're really only allowed to observe in like a select region of the electromagnetic spectrum, unfortunately. Yeah. But I have been to this observatory. I have been to the National Radio Quiet Zone twice. My first trip was in high school, actually. Yeah. This is surprising because people who have been listening to the pod for a while might know that I like grew up in this very small town. I went to what was objectively just like a shitty high school that didn't have a lot of resources. You know, my calculus teacher literally taught me that the natural log was log base 10 and not log base e. Like, it was not a good school. But we had a really good chemistry teacher who, for some reason, decided to take us to the National Radio Astronomy Observatory Green Bank site.
That's
across
really cool.
state lines.
Yeah.
Because we didn't have an astronomy class. I love that it wasn't the physics teacher who took us. It was the chemistry teacher.
Yeah.
Yeah, so it's, I may have been like a junior in high school, and this group of us drove to Green Bank, West Virginia, and we got to spend a night in the dorms. Of course, they like split up the girls and the boys, but but we all got to play like pool and cards in the observatory dorms, so we got to see the other like the astronomers who were coming in and out, and that was really cool. We got to meet them in the cafeteria, and we got to visit some of the smaller telescopes around the observatory. There's this one like shed, essentially, where it's like a receiver is collecting data. I don't even know what type of data it's collecting, but it kind of looks like a lie detector test.
Oh, sure, and it's like dragging the needle on the paper. Dragging the needle, and you get all these spiky lines, and I don't remember why, but we went into that little shed and watched the needle draw the spiky lines on the paper, and then the teacher was like, all right, kids, you did some science, let's go home. Perfect trip.
Mm-hmm. But I didn't know anything about astronomy back then, and so I didn't fully appreciate the trip. Luckily, I got to go back in 2014 when I was a summer student at the National Radio Astronomy Observatory, but at their Charlottesville, Virginia site. They have 3 sites. There's Charlottesville, Virginia, Green Bank, West Virginia, although I think that has separated from NRAO now, and then ALMA, the big telescope array in Chile, is also part of NRAO. So I went back in 2014 as an NRAO student and actually knew about astronomy. We went to the GBT. We climbed up into the control room in the telescope, but we did not get to walk on the dish itself. But we got to like climb up the ladder and stand
really
over
cool.
over the dish. It was so cool. It was so high up.
Did you feel so tiny?
I did. It was like, I have never been suspended above a football field. You know, I've been on a football field.
I'm going to say few people have.
Exactly. Like, unless you're driving the Goodyear blimp or something, like, you're not going to have that experience. But that's what it felt like. I was standing on top of this platform looking down at just like a giant piece of human labor. And I was so awed. It was amazing.
That's really cool.
We also got to go into the Green Bank Telescope control room and see the telescope operators move the telescope. And it's so slow. It's like they press in the coordinates of the thing they want the telescope to point at, and they hit slew so that the telescope can slew over to its new position, and it moves like a fucking turtle.
Yeah, of course it does.
It's a big sloth.
Yeah.
But yeah, that was definitely like a formative experience for me. The second time. The first time, I didn't know what was going on. I ended up becoming an astronomer anyway, but definitely not because of that trip. And the second time, I was just like, you know what? This is really awesome. I'm so glad people are here doing this work. And I did not have a smartphone at the time. I did not get a smartphone until my senior year of college in 2016.
Oh my God, Moiya.
Oops.
That's actually for the best.
It was. Although navigating was really difficult. I would often, like in college when I was going to new places, I would write out the directions beforehand. And if I got lost, I would have to call my roommate and be like, this is what I can see around me. Can you tell me how to get to
Oh my gosh. That is so kind of them to help.
I know.
Also, that's so funny that you needed to do that. That feels like such a thing of the past.
No, well, it is the past, but not as distant.
But not so distant.
Yeah. So because I didn't have a smartphone, like I wasn't taking pictures on it, it didn't have access to the internet, so I was fine. I was not really affected by the rules of the radio quiet zone.
Oh, that's so funny.
Yeah. Any questions about the observatory, Green Bank? Want to know anything else about it?
No, but it does remind me of a video I saw once about how they moved a lighthouse, similar to the one we're in, like further back from the shore. And it was like a super, super slow process where they like were able to kind of put it on wheels and move it back. I watched this, it was like in the lobby of a lighthouse like museum that I watched like 100 times because I was sitting on the bench in front of the screen.
Love those.
And clearly I remember no details from it, but it was really cool to just like see this time lapse of how they moved it back. Those big things have to go so slow.
Wow. Did they like dig up the foundation?
I guess they must have.
That's wild.
It was, the circumstances I was watching this video were so strange because my husband and I were like, this is not a trip I recommend anyone do. We walked across Cape Cod and camped on the way.
Over many days.
And we ended up in P-Town, which was so fun. But we had these like backpacks on us because there's the Cape Cod Rail Trail, which is like really for biking, but we were just like, let's just walk it. it's a trip I'll only do again by car, but we walked to this one lighthouse and they were like, those backpacks are going to be a problem. And we were like, oh, okay. So I sat in the lobby with our backpacks and he went up to the lighthouse because he really cared about it. And I was in a grumpy mood and just wanted to stay in the air conditioning.
Yeah.
So I watched the video like 100 times. And he went to, like, the most humid part of the lighthouse and was like, let's get out of here. And I was like, absolutely.
Mm-hmm. But why were the backpacks a problem?
I don't know. We asked, and they were like, you remember what happened at the Boston Marathon? And me and Eli were like, what?
What?
Like, yeah, I remember. But, like, it was so weird. I don't know what was going on, but we still joke about that today.
Yeah, I would too. Hey y'all, it's Dr. Moiya, and welcome to this episode's mid-break. That big spinning, flashing light actually stopped spinning, and it's now shining right in our faces. So Corinne and I played rock, paper, scissors to see who had to go either move or fix it. Corinne lost, and so I am here to share a few messages with you. The first of which is a big old thank you to all of our patrons who support this show every single month on Patreon. I especially want to thank our sun-like stars, and I really hope that they don't have a bright light shining in their eyes because they are the bright lights of our lives. I am, of course, talking about Sharn Llewellyn, Lissa, and Peyton. Thank you so much. Your stellar gravity is keeping us in orbit here at Pale Blue Pod. And I want to say thank you to our newest red dwarf star, Lilith. Thank you so much. You are joining a truly stellar club, if I do say so myself. You can support us, you can hear your name on this pod, and make it to our patron star chart, all by supporting us on Patreon for just about $1 per episode. And we just started offering annual subscriptions, so you can pay for a whole year up front and get a 13% discount across the entire year. That is 1% for every constellation along the ecliptic, so every constellation in the zodiac. That means if you want to be a red dwarf star, like our new friend Lilith here, then instead of paying $120 per year, you would pay $104 roughly for a whole year's worth of support, and we would really appreciate it. You can find our star chart and our Patreon info and more at our website, palebluepod.com, or if you know you really want to support us financially, you can go right to patreon.com/palebluepod. And if you can't support us with money, that's totally fine. You're still space. We love you. So does the universe. You're awesome. But if you want to help our show grow still, then you can do that by sharing our episodes with your friends and your family. Help your loved ones become friends to the universe just like you are because you listen to our show. All right. Next, I have a question. Do you like mixing your own drinks? And a second question, are you maybe just tired of paying an arm and a leg every time you go out to a bar? If you said yes to either of these, then I think you should check out Shaker and Spoon, which is a subscription cocktail service that helps you learn how to make handcrafted cocktails right at home. Every box comes with enough ingredients to make 3 different cocktail recipes, 4 of each, and they are developed by world-class mixologists. All you need to do is buy 1 bottle of that month's spirit, and you have everything you need to make 12 drinks at home. And if, like me, you lean towards teetotaling, then you can also skip the alcohol and use their ingredients with a seltzer or something to make a really tasty mocktail. At just $40 to $50 per month, plus the cost of the spirit if you so choose, this is a super cost-effective way to enjoy craft cocktails and learn a new skill. And you can skip or cancel boxes at any time. So invite some friends over, class up your nightcaps, or be the best house guest of all time with your Shaker and Spoon box. You get $20 off your first box at shakerandspoon.com/palebluepod. The link is down in the episode description, but just in case, that's shakerandspoon.com/palebluepod for $20 off your first cocktail subscription box. All right, Corinne couldn't fix it, so we're just going to move like 10 feet to the left, which is probably what we should have done in the first place. But let's get back to this episode talking about my favorite observatory in the world. All right, next up, I want to talk a bit about like the history of the telescope itself, not the observatory, and how it came to be. But we have to start with the founding of radio astronomy. When do you think we started doing radio astronomy, Corinne?
I don't know. Like the 70s.
Okay. Okay.
I'm making that up because I really am so bad at knowing when we did things.
Also, like, why would you know that? Like, it's not a fair question to ask.
I'm like, well, that was like a space age. We stopped going to the moon. Maybe we were like, what can we do from here?
I like your thinking. And it is a kind of similar thing happened, but earlier. So it was in the 1930s.
Oh, okay.
Yeah, so we've been doing it. Oh my gosh, we've almost been doing radio astronomy for 100 years.
Wow.
I wonder if NRAO is going to do anything for the centennial, because they totally should in 2032.
Yeah. We'll throw them a party.
Aw. We and the universe will throw them a party.
Exactly. That's the party that we knew they were throwing.
There it is. Okay, yeah, so it's in the 1930s. Radio astronomy became a thing when a man named Carl Jansky was tasked with nothing to do with astronomy, actually. He was asked to figure out why there was static in long-distance telephone calls. And I think when he was given this task, it was explicitly like, figure out which of the thunderstorms are it was assumed that most of the static was coming from thunder, and so Carl Jansky created this type of antenna contraption. It does not look like a telescope, but it is technically a telescope. It kind of looks like the support beams for an old roller coaster.
Okay.
Yeah.
Okay.
It does not look like a telescope, but he made this antenna that could receive radio waves, and he would like point it in different directions to measure which direction had the strongest radio waves coming from it. And he did find that there were some thunderstorms that were causing this static, but there was also this really strong source of radio waves coming from the center of our galaxy. And it turns out that that's like the black hole at the center of our galaxy, and all of the stars and other things swarming in the center of the Milky Way. But it was an unknown source of radio emission. And he was like, that's weird. But it was such a fringe science that he couldn't get any funding to continue the research to figure out what the big source of radio emission was.
Yeah.
And then 5 years later, in 1937, this young upstart, this 26-year-old man named Grote Reber, decided to just build the first radio dish in his backyard.
Okay.
Yeah. So Grote Reber builds a 9.5 meter telescope dish. It looks like a satellite dish.
Yeah.
In his backyard, and that's the first radio telescope.
Oh my gosh. I Googled Grote Reber, and he has the face of someone who would do this. He's just...
What does that
He's just looking directly in camera with a little tiny smile, and I'm like, yep, you did. You went in the backyard and went to build your own telescope.
Is he hot?
I'm not going to say hot, but I trust what he says, I think.
That's a no. When you have to say, like that someone is as smart as they look,
he
like
might
that has
be.
a meaning.
It's really about the personality for me.
Okay, so that's 1937. Grote Reber, Carl Jansky, and a few other radio astronomy nerds, they get together, they start using this telescope, and it finds things almost immediately. And so the rest of the scientific community catches on, and they're like, oh, radio astronomy is actually probably a pretty good thing to invest our money and time and resources into. But it does take another couple of decades for that to become more formal. So in 1954, there was this science meeting in Washington, D.C., where a bunch of astronomers discussed establishing an observatory that was dedicated specifically to radio astronomy. They were like, look, we're making all of these discoveries with these janky-ass backyard telescopes. What if we have a real one that we made with actual money? That was 1954, and pretty quickly they got the funding they needed. There's this nonprofit organization called Associated Universities Incorporated, AUI, and it sounds evil. Like, that name sounds evil.
Yeah, it sounds evil or like a MLM.
Ooh, yeah. Yeah, it's like either an MLM or
or it's like Clark Kent's enemy. Like,
I was thinking it's like the precursor to Skynet.
Yes, exactly.
So AUI is this nonprofit that helps fund and maintain different research centers around the U.S. And they got involved back in 1954. They added some of their own money. They also got money from the National Science Foundation. And in 1957, just 3 years later, they broke ground in Green Bank, West Virginia. So like part of the money that came from NSF went towards buying this land.
Okay, cool.
Within 10 years, they had built 5 telescopes, including a 300-foot telescope, which was the precursor to GBT. And that did really good science. Like kind of as soon as it started operating, they were studying the radiation belts around Jupiter. They were studying comets and asteroids in the outer solar system. They were learning a lot of really cool stuff. They were able to point it to like the center of the galaxy and learn more about what ended up being a supermassive black hole, although we didn't know that for sure until decades later. But then that 300-foot telescope collapsed in 1988. Just fell down.
No.
Just like overnight, boom, no more telescope.
That is nuts.
Wild. And the reason that happened is because they kind of threw this telescope together. They wanted to make a 140-foot telescope that would be like a cutting-edge, super advanced instrument, but they knew it would take a while to build. So in the meantime, they decided to build a telescope twice as big, but like kind of janky about it.
Sure. Okay.
Yeah. And so it collapsed in 1988, 26 years after it was built. It was built in 1962. But after that telescope collapsed, they wasted no time in planning to build a replacement for it. And within 2 years, they had designs and funding to build the Green Bank telescope. The telescope was completed in 2001, and it was named after West Virginia Senator Robert C. Byrd. Although I have never, ever heard anyone call it the Robert C. Byrd Green Bank telescope. Like, they only call it GBT.
Yeah. RCB, GBT. Doesn't work.
Yeah,
doesn't have a ring
too
to
many.
it. Yeah.
Also, like, I don't know much about Robert C. Byrd, but if he was a senator in West Virginia in the 1950s, I'm just
maybe not the best guy.
I'm making assumptions here.
I think it's tricky.
I might be making an ass of myself, but like
it's bad to name stuff after people often. I think no person is free of sin, I guess. but still, it's easier to just call it a thing.
Just call it the Green Bank telescope.
Yeah.
And now we do, so it's fine. If any of you do research what Robert C. Byrd was like, please don't tell me. I don't want to know anything about this man.
Yeah.
All right. So it came online in 2000, and we have learned so much about the universe thanks to the Green Bank telescope. And I have a whole list of really cool discoveries that I want to go through in different like subfields of astronomy. So starting with pulsars, they've been in the news recently. So Green Bank telescope, because it observes in such a wide range of radio waves, it's really good at observing pulsars because they, depending on how fast they spin and like what type of star they are inside, they will be visible in different wavelengths. So GBT can observe these pulsars, and data from the GBT was used in the really big nanograv finding. They recently made a huge announcement, I think just like a couple weeks ago, that basically found that there is an ever-present continuum of gravitational waves rippling through the fabric of space-time, like all the time, which is really cool. Before we had detected like individual instances of gravitational waves, but now we know that just like light, just like photons traveling through space, there are also a shit ton of gravitational waves traveling through space.
I love it.
And part of that data came from the GBT. Part of that data also came from FAST, the really big telescope in China, and other observatories around the world. Another thing that the GBT can teach us about is star formation. The radio wavelengths are really good at studying trace elements and molecules that map on very closely to star formation. So like when stars are almost about to form and when they have newly formed, there are a few molecules that we find in those scenarios. So we look for them when we're trying to find star-forming regions, or when we're trying to figure out like how many stars have formed in a region. We might look at the abundance of those molecules. Like a lot of this molecule means that a lot of stars have formed. My bestie, my fellow astrophysicist in training, soon-to-be Dr. Tierra Candelaria, is that grad student I talked about before who got GBT time, and she is using that data to study ammonia emission and absorption in the galactic center. Ammonia is like we have it in our pee, we have it in a lot of cleaning products. It is also a very useful tracer of star formation.
Oh, cool.
And so she is using it to study star formation in the galactic center so that we can learn what's going on there, how fast are stars forming, and kind of like give us intuition for how the star formation rate in the Milky Way has changed over time, because we don't know if the Milky Way used to form more stars or fewer stars. So we're figuring it out. And shout out to Tierra, because she's doing good work. All right, so that's star formation. We have talked a lot before about SETI. I'm sure we will talk a lot in the future about SETI. But the Green Bank Telescope does a lot with the search for extraterrestrial intelligence or alien life. The precursor to GBT, that 300-foot telescope, and the rest of the Green Bank Observatory, they were used in Frank Drake's Project Ozma. Did we talk about Project Ozma before in the Aliens episode?
Heard of this.
Okay. We might have mentioned it just like briefly, but this was one of the early attempts to find extraterrestrial life. Frank Drake was studying the nearby star system, the Proxima system, to see if it had life on it, and he was using radio waves to try and detect any sort of techno signatures. Was not successful, but it does mean that the Green Bank Observatory has this history of SETI research. Today, the Green Bank Telescope specifically, not the whole observatory, but the GBT is used to help with a lot of breakthrough listen efforts. Breakthrough Listen is part of the bigger Breakthrough project. There's like Breakthrough Listen, Breakthrough Starshot. It's funded by this billionaire who wants to get more more research.
Of course.
Lots of billionaires funding kind of fringe scientific research that other more official organizations deem too risky to fund. So that's Project Breakthrough. Their plan is to survey the 1 million closest stars to Earth, as well as stuff in the center of the galaxy and the galactic midplane, and the 100 closest galaxies to us. So they're studying all of those locations, trying to find some sign that there's alien technology out there. And GBT is useful for that because it can see really far away and because it can see in a big range of wavelengths.
Yeah.
I mentioned this earlier. This is like some of the foundational work to the Green Bank Observatory, but they were studying stuff in our solar system as well as stuff super far away. So they studied comets and asteroids in our solar system. They were able to study the radiation belts around Jupiter. So in our Jupiter episode, we talked about the different bands of color that you can see across the big planet. We've talked about the big red spot. All of those also are associated with different amounts of radiation, and so they were studying the different radiation zones around Jupiter. Some of Green Bank Telescope time went to studying the core of Mercury to figure out if it's molten or solid. We've studied outer solar system moons like Europa and Enceladus with GBT. We've learned a lot more about our solar system, so that's pretty cool.
I love that. Using it for our neighborhood.
For our neighborhood, and also for stuff super far away. So with special instruments that can measure redshift, the Green Bank Telescope has also let us map, or it's helped us map the local universe, because it's been able to tell us how fast different galaxies are moving away from us, and from that we can then calculate how far away those galaxies are, because the further away a galaxy is, the faster it appears to be moving away from us, because there is more space in between us that can stretch as dark energy expands the universe.
Cool.
Yeah. And then the final thing that I want to talk about is these huge bubbles of gas. We're finding a lot of, like, the Milky Way seems to be pretty gassy. Like, I kind of want to give it, like an antacid or something. In 2006, the GBT discovered that there were these huge, and I quote, super bubbles of hydrogen gas rising nearly 10,000 light years out from the plane of the Milky Way galaxy, like the flat part of the disk. It could be from supernova explosions. It could be from winds being blown off by very young, hot, energetic stars. Since then, we have found other big gas bubbles. We know that there are big gas bubbles right around the supermassive black hole in the center of our galaxy. That was found with telescopes in South Africa. And so, now, thanks to GBT and other big radio telescopes, we know that the Milky Way should probably stop consuming as many milky products.
Yeah, maybe.
Or like maybe it doesn't care, because I'm also a little bit lactose intolerant, so I'll drink lactate, but like you cannot take cheese away from me.
No. Oh my God, same. I remember talking to my doctor. He was like, well, you could try going dairy free for 30 days. And I was like, no, I'd rather live like this.
Because sometimes, even if we know something will make us healthier and like make us live longer, if it's going to be a longer, more miserable, cheeseless life, I don't want it.
I don't want it. Maybe one day. Maybe I'll cut back, but I can't eliminate.
Yeah. I cut back by drinking lactate, and I don't really have ice cream anymore.
Yes. Oh, God. Ice cream is not it for me.
Shaved
even though
ice
I
or
love
something?
it. Yes.
I love it. But I'm saving all of my dairy budget for cheese.
Yes. Respect.
Thank you. That's all I had prepared about the Green Bank Telescope. Do you have any questions or like reactions?
I think it sounds really cool. I love how big it is.
That's what she said. I'm so sorry.
Imagine.
I'm so sorry.
I walked right into it. It's fine.
You did.
But I do have a little game.
Oh, I love a game.
It is called Is It Bigger Than the Green Bank Telescope? Okay, so I picked a series of famous, things. And then we're going to guess if the Green Bank Telescope is larger or smaller than the thing I picked.
Are we talking mass or volume?
We are talking height. Or not height, but like the diameter of the Green Bank Telescope. Is it as long as these other things?
Okay, cool.
Because weight-wise, it'll never work.
It will never work. Things are really heavy.
Few things are 17 million tons.
Yeah.
Okay, Big Ben, the famous clock in London.
Oh, that always looks short to me in pictures, so I'm going to say it's smaller.
Yes, Big Ben is smaller than the Green Bank Telescope. Big Ben is 96 meters, or like 315 feet.
Oh, okay, so it just makes the cutoff.
Yeah, and GBT is, as a reminder, about 100 meters.
330 feet.
Exactly.
And it's not a perfect circle, FYI.
Oh.
Like it is kind of an ellipse.
Yeah, that makes sense. I think, is that true of all telescopes? Like of the last one we talked about?
So the difference between, one of the most important differences between an optical telescope and a radio telescope is that the optical telescopes are usually like flat and they're a mirror. You might see like a little bit of a parabola shape, like a little bit of a dip. These radio dishes are parabolas. They are like a very shallow bowl.
A TV antenna kind of style.
Mm-hmm.
Yeah. Okay, so let's think of a giant sequoia tree.
Oh, I want to say bigger.
The tree is 76 meters. So the telescope is still larger than the tree.
Still large. Oh, wow! I was picturing the like slice, the sequoia tree slice that they have at the American Museum of Natural History. They have that big one on display. So I was picturing that, and even that is smaller.
Yeah, they're 250 feet.
Wow. Okay.
Yeah.
Okay.
What about the Great Pyramid of Giza?
Bigger.
Yeah, the pyramid's bigger than the telescope. The pyramid
also by mass, certainly bigger.
Yeah. The pyramid's 130 meters.
Wow.
Which is huge.
Wait, now I need to know the mass.
Oh, yes, please find out.
And how would they even measure that?
I know. I don't know. I guess they're measuring a piece and then multiplying? What is it?
Corinne.
Oh, no.
Corinne, it's almost 6 million metric tons, which means it's over 13 billion pounds.
That is way too big.
That's so big. And that was all built by people.
I know, that's what I'm thinking. I'm like, somebody hated that job.
Yeah. Oh,
if
I'm
not
sure.
everyone.
They all, they were not there voluntarily.
So true. Wow, that is way too big.
It's too big. Okay, but bigger than a telescope.
Bigger than the telescope. Okay, what about Cinderella's castle?
What?
Cinderella's castle at Disney World.
Disney World. Okay, I was like, from a fairy tale? Why not just go with Sleeping Beauty's tower?
Oh, yeah.
I want it to be smaller.
The telescope is larger.
Good.
Because the castle is 57 meters.
Oh.
But,
so it's a good bit bigger.
Yeah. But the castle, okay, so in the light research I did for this game, the castle's architecture uses forced perspective, which is an optical trick. So the castle gets smaller at the top, so it appears even larger than it is.
Oh, that's smart.
Isn't that cool?
That's sneaky smart.
Yeah.
I like it.
Very Disney to do that. Okay, what about the Space Needle?
Ooh. I have been at the top of the Space Needle. And I want to say, based on my memory, and this, I know this is, like, my memory is not this accurate, but I want to say that I felt higher up at the top of the Space Needle than I did at the control room in the GBT.
And you were, because the Space Needle's 184 meters.
Oh, shit.
So GBT is smaller for sure.
For sure. Oh, good for you, Seattle.
Yeah. You need something.
You need something. Because all that gloom and rain is going to make you sad unless you have a really tall needle.
Or unless
nearby.
you have, what is it, Forks, Washington? The location of Twilight?
Yeah.
Unless you have a vampire and a werewolf chasing after you in a love triangle. You need something to keep you happy.
You do. That would be enough to keep me happy, but I don't have access to that. So yeah, we need the Space Needle.
Okay, final one. The International Space Station.
Is higher up.
Well, higher up, yes, but I mean like the length of the space station.
Oh, that's a good question. I always think of the space station as like a small thing.
I feel like in space terms it is.
Yeah.
But
I feel like you are putting it on this list to throw me off, and I'm going to say it's bigger than the GBT.
Okay, so the space station is the length of a football field, so it's really close to the length of GBT. It's 109 meters.
So you could
not too far off.
But that does mean that, like, you could kind of fit the International Space Station on the telescope.
Yeah. I mean, and like the area where the aliens live, the area where the astronauts live is not that long. That's like end to end, including the solar panels. But yeah, close. They're friends, I imagine.
Yeah. I just looked it up. Would you like to guess how much the International Space Station weighs? Well, do you think it's more or less than GBT?
I think it's less.
Mm-hmm. It has to be sent up into space.
To be up in space, I'm like, a
absolutely.
lot less. Like, I don't know,
a lot less.
A quarter of what?
Way less. So if GBT is like 13 million pounds, this is less than a million. It's 925,000 pounds.
Okay, good. That's for the best. I don't want that falling onto Earth.
Right? Well, you also don't want to have to spend the money to send it off of Earth.
Send that, oh my gosh. When I wrote a pilot about sending them into the moon, there was a joke in it about it's cheaper to send women because statistically they weigh less than men. So if it costs $10,000 a pound, like...
We're right. We should get the tiniest people.
Exactly. We just send children, I guess.
Well, there are parts of the country dismantling child labor laws as we speak. So maybe one day we will have child astronauts.
Oh, I hope not. That would be horrible. Cute, but awful.
Cute, but like imagine their little spacesuits.
I was just gonna say the little spacesuits, but I don't think they could do the complex experiments we need.
Probably not. They would have to be coached through it.
And they don't listen. If there's one thing I know about kids.
You're right.
Well, that concludes our game. And I hope everyone has a great vision of how big this thing is now.
Mm-hmm. Thank you for that game. Thank you for your questions about the Green Bank Telescope
Anytime.
as we go through. I hope you get to visit it one day.
Me too.
But listeners, no matter how big you are, you're still smaller than the Green Bank Telescope, and you are still space, and you're smaller than the universe.
It's true. Okay, bye.
Pale Blue Pod was created by Moiya McTier and Corinne Caputo with help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen. Our audio editing is handled by the incomparable Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Twitter and Instagram, or check out our website, palebluepod.com. We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
If you want to support Pale Blue Pod financially, join our community over at patreon.com/palebluepod. For just about $1 per episode, you get a shout out on one of our shows and access to director's commentary for each episode. The very best way, though, to help Pale Blue Pod grow is to share it with your friends. So send this episode, this link, to one person who you think will like it, and we will appreciate you for forever.
Thanks for listening to Pale Blue Pod. You'll hear us again next week.
Bye.